Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Synopsys. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share with the rest of your team, we will send you an email after we conclude today, and that email will provide the on-demand recording. So keep an eye out for that after we conclude our program today. If you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions for Stephen, we do want you to send those into that Q&A tab on the right side of the chat section. We'll be keeping track of all of your questions, and we've got some time set aside at the end to address those. So please do send those in throughout, and we'll be sure to touch on them. Additionally, if you jump to the handout section, you'll see there are a couple of resources there for you. So feel free to grab those while you're with us. And as an advance notice, we do have 2 polls that we'll be launching throughout our program today. So when you see those slide out on the left side of your screen, please do respond. We'd love to incorporate your feedback into our messaging today. And last but not least, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, your questions, and to fill out our post-webinar survey that is attached in the handouts, but I'll post the link in the chat toward the end of our session. So today's topic is AppSec automation, 5 steps to achieving developer-first security. I'm joined today by Stephen Zimmerman, DevOps Security Solutions Manager at Synopsys. So Stephen, thank you so much for joining us today. It's been a pleasure speaking with you up until this point, but I will turn it over to you to fly solo for a little bit.
Great. Thank you very much, Cody. So as we mentioned, welcome and good day. I am Stephen Zimmerman, DevOps Security Solutions Manager here at Synopsys, and we're together here today to explore 5 steps to achieving developer-first security. I recognize that we have a variety of professionals here with us today. Some of you may spend your time on security teams, some perhaps on development or engineering. Others may be focused principally on DevOps or cross-functional workflows. So with that in mind, I put together a few things that should help move the needle, regardless of what your focus is, to help me understand where to spend some of my time and to focus the discussion. I've put a poll up on your screen just for your quick participation. That's accessible as a pop-up on your screen now. So this will help me understand who's with us here today and how I might provide a little bit more helpful guidance. So as you quickly select your responses, I'll just break down the agenda. We'll start with a little bit of level setting on some of the issues that many or all of us are facing, the things that we're trying to solve. And then we'll transition through how and why development teams are sort of on the front lines of our AppSec programs. And then, of course, I will outline a 5-step plan that should help you envision the next steps for structuring your DevSecOps program, or at least fostering the conversation with some of your peers in other departments so that you can all work together to, toward whatever security goals your business has set for the year. So with that, let's set the scene. Basically, I think generally we're all accustomed to the notion of DevSecOps, right? Talking about waterfall development, it's not really relevant. It hasn't been for several years now. But DevSecOps, within the context of our conversation today, is basically a concerted effort across teams to keep the software pipeline flowing in a way that balances your delivery schedules with your security requirements. And that's a really simple way to summarize it, but organizations can make this happen in a bunch of different ways. And I think it's often that lack of definition that can trip people up. And because there's really no one way to achieve DevSecOps. So categorically, there are 3 ways that I see things tend to fall flat when you're updating your DevSecOps program. First, there's this broad spectrum of security pressures, right? This is really the notion that we've got such a variety of risks, and so many ways that we can use to find those risks. In a lot of people, you can think customers, partners, regulatory bodies, governments. There's a lot of people with a vested interest in the level of security that we bake into our software. Each of those, each of those components, they all need to be managed. And we've seen that 70% of organizations, they're using more than 10 application security testing tools, just to cover that spread that we see in that first box. So the security pressures are growing, internal and external security pressures, they're growing. And then we've got, in the central box, we've got all this high velocity development going on. That's made possible by our friends over in DevOps. That's CI/CD pipelines, things like that. But every company is now a software company. So whether you've got an app that's, maybe it's where you showcase your products, or you have an e-commerce portal, or you have a customer portal, then there's all this internal software development that supports business functions, right? You've got SQL servers for all those 30-year-old finance databases that you're keeping on life support. You've got maybe an employee intranet or a communications platform, things like that. There's all this development going on to keep things running. And not all of it is generating revenue, but it's all handling potentially sensitive and potentially valuable information to attackers. So, of course, we're prioritizing what to fix. And we're noting that about 50% of our organizations, they report regularly pushing vulnerabilities, or rather regularly pushing vulnerable code. They select the most recent for doing this as meeting deadlines. So these two categorical challenges exist amid a very complex software development and delivery pipeline. We've got different development teams using different languages and frameworks. They're shipping them through distinct pipelines. And so because of this, there's this realization that technologies need to be tested in different ways, or you run the risk of not detecting some issues, or of sidelining productivity, maybe because you're raising alarm bells, because there's a hair in your code, so to speak. So we end up with the plurality of organizations, more than a third of which we see in this data point, identifying integrated and automated security testing as being key to a successful DevSecOps program. Now, we can align these things. That's the whole part of having a DevSecOps program, right? We can plan for these things and we can align to them. But operating in a way that separates AppSec from development workflows, that's where these issues start to manifest themselves. So these challenges that we just talked about, they can affect developers greatly. Development teams often, they've got their own sort of mini workflows that kind of exist, kind of within and tangential to DevOps workflows, or that DevOps infinity loop that you might be familiar with. So they've got too many of their own development tools to run and manage, let alone anything additional as prescribed by security, because that might create additional friction. And this frequently varies by team, by project. Maybe you're part of a corporation that's has acquired or spun off business units, and now they have their own budgets and they have their own tech stacks. So for many people, where security is often centrally controlled or it's centrally defined, these diverse tech stacks, they're a headache. And for developers, being prescribed security standards that they simply don't work in their workflows, it's untenable, and it introduces a lot of potential points of failure. Next, they're also trying to balance code quality with development speed. They're trying not to introduce new issues into their projects, but they're still trying to meet those aggressive deadlines for all that software that we just talked about. So when our security tests are taking longer than our development cycles, longer than our incremental code changes, or when our pipelines, maybe they feed directly into production, unless somebody hits the pause button, it's hard to have a consistent way to establish security without derailing everything. So that's a negative impact on time. But when there's a cost to that rework that's being dictated by the security team, again, we start seeing these negatives building up. Excuse me. But I mentioned that we can plan for these challenges. And part of that planning is informed by having better visibility and better feedback among developers and among security teams. But alerting developers to every detected issue without regard for its priority or for its fix recommendation or whether or not there's even a fix available, that's distracting. And it makes it impossible to drive a concerted push for DevSecOps when one team's unable to attest to what's reasonable because they lack some helpful insight into risks and standards. So these one-directional open loop communications from security to development, that means that there's very little context for delays when there's little assurance of security. So it almost becomes a lose-lose situation for anyone involved. So with no continuous normalized feedback, different priorities or obscure remediation requirements across all these varied tech stacks, there's a lot of confusion among development and security teams, and that makes scaling secure development a really big challenge. So all those potential points of failure that I mentioned, when one aspect of this already fractured pipeline changes, then we're left with having to rethink and swap out potentially large aspects of our security program, and this will not end. It does not scale. So how do these changes or these hurdles or whatever euphemistic name we want to choose to give them, how does that manifest as risk, or how does it manifest as a reduction in security? Well, we've garnered a good deal of insight in our global state of DevSecOps report this past year, some of which I've highlighted here on the right for you, specifically focusing on this impact of misaligning security and development. So we know that our dev team's priority is to code new functionality and to improve our applications. And while security isn't necessarily their role, through them performing their role, developers greatly influence security risk, especially as they push more code and when we've got more frequent releases going through the pipeline. And so if you think back, remember that we had about 50% of organizations saying that they knowingly push vulnerable code. And here we've got 38% testing business critical applications less than weekly. So depending on how many releases you're doing, this might be totally fine. Or this might be dangerously slow given multiple releases that are possible within that same time frame. So visibility is still an issue, right? At least when you don't have a unified DevSecOps program, visibility is an issue. And so this 36% of organizations that have cross-functional teams, that is encouraging to see that there's some investments to increase risk visibility throughout the pipeline and kind of break down those silos. But when that only results in our third data point of 5% being able to resolve critical issues within a week, we're not really seeing a reduction in our risk exposure just by investing in increasing visibility. And that's because finding it is only half the battle. Fixing it is the other half. So we've got this combination of testing and time to remediation, and those fit along that timeline that you see in front of you. We're writing our code, and we're bringing in open source dependencies, beginning on the left side there of our timeline. And now at some point, a vulnerability gets published for that open source, or as is the case when we write code, we've got a weakness or a vulnerability baked in from the moment that our devs write it, or if they unknowingly select an already vulnerable third-party library. And it takes some amount of time for us to discover that security issue. And so, we can already start to see that we can shrink this timeline down as we perform more frequent testing, or perhaps with more security capable developers, which we'll explore a little bit more in a moment. But Then we've got to select a new open source library or find a patched version or refactor code that we wrote. And then we need to push that security update out. And so this right here is the window of opportunity of an attack. And that window could be open already, as you see with that lighter red color on the left. That window of opportunity may already be open from the time development starts. And so this right here, this red, is what we're trying to shorten with our DevSecOps program. The more that we can abbreviate this, we lessen our risk and we increase our security posture. And we benefit the business by way of our AppSec program. So customers, partners, they want to see this red timeline gone or as small as possible. They want attestation that you have quick, automated, resilient ways to tackle this before they give you their business. So this red spreads out if we can't balance the equation of quick releases and tight testing windows. It spreads if we don't foster risk visibility and do that effectively across our tech stacks. And we need to understand, as we see with the data on the right, we need to understand the difference between security risk awareness and security capabilities, because that's going to involve a few different teams to do it properly. One of those teams is developers to support AppSec. And that's not to work in parallel or oppositional to AppSec, but more of a lockstep way that's aligned to the needs of the business and to security. But we already saw that defined as a success factor for DevSecOps, right? A concerted approach to security that includes developers in a way that moves forward with AppSec. But not all developers share the same experience or knowledge regarding application security or secure coding practices. So most organizations are experiencing this firsthand. We've got all this new development, which means increasing staffing for developers, often. But security is not standard among these programs or among these developers. So developers could be weak links for security if they're not enabled or trained properly. Our DevSecOps programs, they need to account for this by enabling developers to help us realize security as they write code. And in our first data point here, 88% of developers already know this, but only 14% view AppSec as a priority as they write code. And so we can see how this manifests, right? Developers' role, like we said, is to code. And through them doing that, they impact security. So their prioritization of security comes secondary to them meeting their shipping deadlines. And so between our second and our third data points, we know 76% of developers believe that security training would actually help their productivity. Why is that? It's because there's all this rework that comes from failing security tests. And when those security tests happen downstream, our developer workflows just go right out the window. So late stage testing, late stage security testing, it's going to raise our developer security risk awareness, but it's not really supporting their development goals. In late stage security testing, it tends to mean that our security teams are then really churning through that big issue backlog, those lists of thousands of vulnerabilities in a project or a branch. But bolstering that security capability part of the equation, that's going to start reducing the rework. And it's going to start supporting our shipping deadlines. It's going to shrink that issue backlog. And it's going to make sure that we fix things faster and abbreviate that window of opportunity for an attack. So embedding developer security training, that's not, I don't mean the generic stuff that you would do for HR compliance, but training associated with the risks that our tests are finding, embedding secure coding education into our workflows and our DevSecOps programs. That means that we're reducing duplicative work that's distracting us from new development. And basically, we end up becoming more secure, more efficient, and ultimately, we generate a greater ROI on our security program. Because we can basically turn security from a cost center to a business driver. We become more trusted among our customers and among our partners who are seeking attestation of security. and we start to accelerate security and development more in unison. So, and excuse me here, this, the title's a little bit obscured, but we found a sort of 5-step plan to establish developers as a first line of defense against software security risks, and a way to do that which scales, which can adapt and which can evolve, and one which provides a mutual benefit for developers and security teams. I kind of playfully regard this as 5 steps to align security and development without breaking things, because I think that's maybe a little bit more true to what we're trying to do here. And so first, we need to meet developers where they are. That means understanding how development and engineering teams define success, the tools and processes that they're using, so that we can help inject security risk awareness and security capability. There's those 2 fundamental elements again. Inject those 2 aspects of security into what they're already doing, and help them support security without deviating from their established workflows. And the next point then, our step 2, to achieve that and to help accelerate it, we're going to integrate various aspects of security testing into the SDLC and into our CI/CD pipelines. We're integrating those things so that we can establish automated security gates that helps to, those automated security gates are going to help security teams have a way to manage risk without having to increase their manual effort. And so that we can close that loop with development teams much more quickly, as close as possible to when that risk is introduced, so that we can fix things quickly or just avoid them altogether. Integration here, since it's a bit of a buzzword, integration in this context really means using triggers and policies to really reflect what our actual goals are and what our requirements are for AppSec. And it means that runs as our pipeline runs. So it's not just reporting, it's actually functional integration, just to clarify. And step 3 is actually my favorite one, because this is where, we can really start to make some huge strides toward security while also really optimizing our DevSecOps program for to be more efficient. We're going to use an automated way to turn functional tests, which we're already doing, and deriving security risk information from them. And since we're doing this in pre-production runtime, we're not going to burden down or over-encumber production environments, and we're able to see the risks that manifest in runtime and whether they're actually exploitable in context. So we can begin to eliminate many of those false positives, and we can prioritize the issues that are really among those with the biggest potential impact on the business. So number 3, for me anyway, is a really interesting one. We talked a bit about number 4, or elements of number 4 earlier, but we're cultivating developer security capabilities. We're helping to standardize our expectation of security and what we can do to support that while coding. And we're cultivating a more technical workforce that helps make more secure software over time. So we'll fix faster once we start doing this, and we will preclude new issues as well. So blending this one with numbers 2 and 1, getting them the risk-relevant training in their workflows, that's the key to really elevating this beyond simple continued education for developers. And lastly, number 5 here, we're architecting this DevSecOps program alongside a strategy that can evolve with the business. This is a very important part because pipelines change, goals change, requirements, standards, expectations, they all change over time. We'll get more development and we'll have new apps and new projects. They'll be built atop new languages and frameworks using new pipeline tools. We do not want to build this plan over and over and over again. So we'll use policies that work across many of our security tests. And we'll centralize and prioritize the risk intelligence that we get from those tests. We'll do that atop a security testing platform so that we can start consolidating all of those various legacy testing tools that we inherit over time. And then we can really start to accomplish all that requisite management and program refinements all in one place. So what we see here, this 5-step process, this is tenable. This is one where we can start at any one of these places. These are not necessarily sequential, but we get a sort of accretive benefit from each of these the closer we get to implementing all 5. So that's kind of the conceptual nutshell, right? For those of you actually looking to take the next steps to solve some of your more strategic DevSecOps problems, in the next part of our discussion today, I'm going to make a few recommendations referencing specific solutions. I'll try to clarify, to whom the changes and the benefits that we start to see. I'll try to define for whom that matters, and so that you can start bringing those benefits to your colleagues, start building support for the next phase of your DevSecOps program. And then I'll show you where in your pipelines you can implement each of those solutions so that you can balance security coverage with efficiency. So with that, we'll start with number 1, with meeting developers where they are. We're first going to keep developers from engaging in extraneous workflows outside the development workflows that they're already plugged into, because we can't have security derail DevOps. And moreover, we need to realize that the least impactful vulnerabilities are the ones that never even make it into the project and the ones that don't get pushed downstream. So we obviously see some more security benefits here, fixing things from the start, making more secure software from the get-go. And then we also have some serious efficiency benefits. So anyone in DevOps, anyone focused on smooth development or CI/CD, you're going to win those people over as well with this first point, because in terms of a closed loop security program, the tightest loop is hitting, writing secure code and then hitting save. So this means using things like Synopsys CodeSite, where we're basically testing both custom code and open source for quality and security issues. And we're doing this while the developer is coding in their preferred IDE. So what's great about this is that the developer is going to know right away, before they commit, that there's new issues in their projects. So anything new that they've written in, like a CWE or other things may be covered in the OWASP top 10, any open source components that they've declared that might already have existing vulnerabilities, or really which may become vulnerable, may have become vulnerable since they last worked on the project, they'll see all of that without leaving the IDE. So IDE-based security testing, like we can do with Synopsys CodeSite, where we're giving developers what they need to find and fix issues right away. So that includes remediation guidance from our cybersecurity research teams, because again, the developer, they would likely benefit from some assistance knowing how to code out the issue or which new library versions might have no known vulnerabilities. So we give this to them in the IDE, and we give this to them throughout their issue management workflows, Jira or Slack or whatever your issue management workflows may include. We give them the information that helps them fix the issues, and we align everything that we send to them with policies and standardized risk scoring so that we fix the highest priority issues first. Because remember, and I think this is an important point to reiterate, we've got one eye on security here and we've got one eye on efficiency. So we don't necessarily need developers to chase down insignificant vulnerabilities if our security policies would otherwise say to disregard them. So this interoperability, this will help satisfy any colleagues that you have on security teams who might be of the mindset that developers should not be making the subjective assessment or defining a subjective metric for what secure means for any given project. So we can have developers just carry out their standard workflows. I think in the screenshot on the left, I have an example here where, we're making a commit in GitHub, maybe GitLab, Azure DevOps, things like that. And we can make an assessment at commit, or even just set standard intervals in our repos when we make assessments. We can automatically trigger a scan, automatically comment a pull request, or open a fixed pull request. So with this first step alone, you can see that we're starting to abbreviate that window of opportunity for an attack. That then sort of gets us into the integration conversation and the automation part of today's discussion. We're supporting developer workflows while we maintain control over our security risk posture. So this is really going to make your DevOps and your security colleagues very happy, because this is where we sort of ensure that we broaden our security coverage across the full SDLC, across our end-to-end, CI pipelines. So we will be able to run various types of security testing on source code, open source, on compiled binaries or third-party artifacts. We'll do this at each major stage in the pipeline so that we can accomplish two things. We want to find issues that we've introduced as early as possible, closing that loop with dev right away. And we're going to find issues that enter our code base through those inevitable unapproved alternative pipelines, we'll call them. These are the pipelines that developers often have so that they can play with things, they can innovate on their own, but that tends to be outside the scrutiny and the accountability that comes from having those more controlled or more secure pipelines. So we need to account for those because they do exist. They pop up as a path of least resistance, and they leave us exposed. So if we just assume that earlier security tests in one pipeline will catch everything present at that stage, we're not accounting for things that enter later from these mysterious unapproved pipelines. So what do we do? How do we stop that from happening, or how do we plan for that? We reduce the friction and we make our security approved pipelines the path of least resistance. So we establish security gates so that we stop the propagation of issues. We keep that control over what we consider, I guess, meaning general security-oriented professionals. We keep control over what we consider to be risky and what we consider to be secure. And we keep that within security teams or whoever's responsible for it. And we ensure that our projects become more secure over time as dev teams fix those priority issues and begin to elevate their security standards. So what's great here is that this integration and this automated testing, it's going to help us defend against supply chain security risks as well. That's all that stuff that comes from third-party vendors or maybe from contractors or things like that. Those don't always enter early in the SDLC, right? In some cases, they come in as binaries, or maybe they pass through some pre-production security testing and then they go out into the wild. So these integrated security gates make sure that everything is going to pass muster before we push into production. Overall, we're fixing faster, which security practitioners love, and we're growing the ROI for our security program, which businesses and leadership, they love that. So like we discussed before, security controls and this automation, those are our attestation to the people who want to place their trust and their capital with us. We're helping the AppSec team, and we're helping our DevSecOps program become a revenue engine and not simply a cost center. So with number 3 here, as you may recall, it is my favorite. We're going to try and get more testing without running more tests. We're going to do this with an interactive application security testing, or IAST, solution. In my example here, I'm using Synopsys Seeker. You might be familiar with IAST already. Maybe you're not. In essence, it's like gray box testing, or like like having a team of virtual pen testers available 24/7, and it functions in a much more accurate and faster way than doing traditional pen testing. But we're going to plug our Seeker IS tool. We're going to plug that into our CI/CD pipeline so that all the functional testing that we're already doing, all of that gets transformed into very precise security testing. And that happens automatically without really any extra effort outside of that standard workflow. So what's really cool about this is that we're able to layer automated security risk analysis on top of both our automated and manual functional tests. So our DevOps teams, they tend to really like this. And so that's going to do a couple things for us. It's going to enhance our ability to detect vulnerabilities that maybe we missed them in previous security testing, or maybe they're vulnerabilities that only manifest in runtime. This also means that we're more capable of detecting risks that we ingest through our software supply chain as well. Maybe the ones for which we had no source code, so we couldn't have analyzed that during earlier security testing, for example. So with this approach, with our IAST tool, it's going to automatically retest detected vulnerabilities so that we're then verifying not only that we really have a vulnerability here, but also that it can be exploited. So this means then we get a clear list of exploitable issues with almost zero false positives so that any triage that we perform here is based on real risks. So we're going to do this for everything like our web apps, our web APIs, our serverless functions, containers, microservices, all that kind of stuff. And it's going to enhance our ability to support data protection compliance as well. So that's like PCI or HIPAA, GDPR, things like that. So we'll apply that policy-based approach to AppSec that we talked about earlier. We'll apply that here for compliance standards or other standards that we have for risk tolerance. And we'll do that to automate our feedback to dev for that faster remediation. So ultimately, this lets us, it really helps us extend security beyond just the exploitable vulnerabilities all the way to sensitive data leakage as well. So we'll define parameters and patterns for what sensitive data actually looks like in the context of our systems and the context of our applications. And so that we actually can identify risks to that sensitive data that our applications are touching or transmitting or storing or accessing. So this pre-production testing, this is going to let us watch what's executed and when, and which data is transmitted or accessed, which protocols are invoked, things like that. So what's really outstanding here is that it helps ensure that your security risk posture isn't limited by the security inadequacies of somebody else. We're constantly ingesting software that's composed of I use quotes here, composed of secure, vulnerability-free components, but they may contain malicious artifacts. And we only find out that they're malicious when we put them in a running state and when we start observing that data flow. So as this functional security testing occurs continuously as part of our pre-production testing cycles, pre-production functional testing cycles, we get this real-time data that we can then add to our collection of our risk insight, which is fantastic. It really rounds out that risk awareness side of our DevSecOps program. And remember, though, we have that security capabilities side that we have yet to sort out. And so number 4 is going to help out with that. We cultivate security-capable developers. We're setting out to abbreviate that window of opportunity for an attack, and we're trying to become more secure over time. That's going to make everybody happy, really. If I'm trying to focus on roles and responsibilities, developers enhance their professional skills for security. They avoid rework from failed tests. Security teams love this because they get a steadily decreasing backlog of issues that they have to review and prioritize. And then DevOps teams love it because it happens as part of predictable workflows and delivered in these kind of risk-relevant modular chunks, rather than prescribing, complete learning courses or things like that that might otherwise be misaligned or not aligned at all to our risk tolerance or the risks that are in our software. So Synopsys and Secure Code Warrior, we've partnered, to work toward exactly that, allowing security, dev, and DevOps teams to foster a culture of security from the start in a way that aligns to the business goals and that delivers training in a way that doesn't derail workflows and in a way which it really suits the various learning styles. So whether a developer is an autodidact or maybe they're more of a visual or an interactive learner, it's important to understand that developer security training in this context, it's aligned to our goals to reduce our security risk exposure. Again, it's not just a checkbox that we check to say that we provide security training to our employees. I think those of us here recognize that there is a need for that, but that's not our focus with our DevSecOps program. So we're using secure coding education in DevSecOps as an extension of remediation guidance so that we're helping developers fix issues that we find as quickly as possible, and then also helping them not to introduce those issues again in the future in other branches or other projects. So we integrate developer security training across the SDLC and into issue management workflows again. So developers can access that security training from the IDE related to the issues they detect. They can get recommendations associated with risks assigned to them through JIRA or things to that effect. So again, this is strengthening what we consider to be our front line of security defense. So to make sure that our advances in security are consistent and resilient, we need to plan for the evolution of our development pipelines. We need to plan for the evolution of our security requirements and our risk tolerance thresholds. And we need to plan for the evolution of the software that we're actually putting out into the world. So organizational pressures loom heavy over this part of our strategy, we'll say. The way our business itself changes shape, the companies that we acquire, the partnerships we form. So we need to minimize the potential points of failure, and we need to minimize our overhead. So consolidating our security testing tools to a platform that can run all those various application security testing engines, run all those scans, and one where we can set policies that define under which circumstances our scans run, that's going to simplify the management of our DevSecOps program so that we can adapt more easily and more readily to those changes that are really inevitable. Here we're doing that with the Polaris software integrity platform from Synopsys. So that's going to underlay this whole integrated DevSecOps program, and we're going to run this as a service, as a cloud-based security testing platform. So we don't need to go chasing down 5 different admins across 8 different tools to get a report of risks that we found in a given project. We don't need to make sure that every policy for every tool is up to date and that we didn't accidentally let something through that we've otherwise prohibited since a new vulnerability hit the headlines, last week, for example. So here we've got centralized control of users, of teams, of projects. So regardless of how many pipelines we have across all our business units or across our clouds, multi-cloud environments and things, we can connect all of them through this platform so that our results across all of our tests, which we run at those various stages of the pipeline, they all go into one place. And then we correlate them against our policies. And then we deliver those via those closed loop issue management and workflow integrations that we talked about. So then we're sending really clear guidance to our developers on where an issue exists within the code, within the file structure, which contributing events, invoke exploitable conditions. And then we recommend a patch or that modular risk relevant training on how to fix that specific issue. So in terms of benefiting development teams with a security platform like this, we're automatically onboarding new projects as they're created, right? Because we've done that integration with our SCM. So devs, they just do their innovation. And And then we have those safety nets for them in place to ensure that any new projects or any new branches adhere to the security standards that we need them to. An AST platform like this is probably going to make one of the greatest impacts on all 4 of our success criteria. We've got that, that high velocity testing that allows for high velocity development, right? We've made efficient use of our resources for impact and for return on investment. We've integrated aspects of this across our pipeline, so we enable every team to support security more as a unified front. And then ultimately, we're really just ready to evolve and to do that at scale as our development and our organizational activities shift. But what's great about this is that it works while you're away, so to speak, so that your security status, it sort of passively regenerates while your AppSec and while your DevOps teams focus on enhancing other areas of your pipeline. So as we start winding down the discussion, I have one more poll for you, which you'll see on the screen momentarily. So thank you again for your brief participation. As we've discussed, many ways to accelerate and automate an integrated approach to DevSecOps with developers on the front line. I would like to know how you assess your current AppSec automation maturity, we'll call it. Are you beginning to automate testing and risk detection? Maybe you're automating parts of issue tracking and triage. Maybe you're even implementing some automated patching, depending on the security tools that you're using. And maybe many or none of these describe you. But as you finish your response, I'd like to give you just a quick reminder of that 5-step process again, that 5-step process to supporting DevSecOps more effectively and more efficiently. So you can do that again with much greater success by focusing on developer security capabilities, facilitated by earlier risk awareness, and turning this into a unified, concerted push for security that's going to evolve with our pipelines and with our business. And then, let's see. So I thank you for your participation in the last poll, because I can really start automating, or rather start aligning this to our SDLC really, really quickly. So we can better visualize how this is going to come together and manifest as an actual DevSecOps program. So beginning on the left, we're doing that somewhat cliche or off-used phrase of shifting security left. Maybe here it's more accurate to say that we're shifting security everywhere. So to help developers write more secure code and avoid that late stage rework, so we're going to run SAST and an SCA in the IDE and in those SCM code repos. And then we're going to do more centralized SAST scanning throughout the pipeline, integrated at build and in our repos. So at this point, when we're doing this integrated SAST scanning, which is more central on your screen there in that purple box, this is where it's often already out of the hands of our developers, who have since moved on to another branch or another version. So anything detected here and sent for remediation, anything detected here is going to have a greater risk of impeding our dev and DevOps workflows when we ultimately have to fix it. We're going to do the same for SCA and finding known vulnerabilities in the open source components. And we're going to do that for the components that our dev teams declare when they write the code. But then also, because of our integration here, we're getting those transitive dependencies that also they come into our project when we run the build. So we're not going to run SCA scans persistently, nor should you. But because we already know which components, versions, distros we've incorporated into our projects, we can continue to monitor for new vulnerabilities that come out any day in the future. And we can instantly trigger alerts and kick off those remediation workflows based on the fact that we already have this that asset snapshot, that software bill of materials in hand. And then we're going to run IAST alongside our functional tests to observe data, the data that's accessed and transmitted, insecure configurations of web apps, anything that's going to really manifest at runtime. And we're also going to use this as that additional layer of risk verification for our prioritization and triage. Because a vulnerability that we detect way back here, farther left along our timeline, it may not realize exploitable conditions in runtime. So we can actually de-escalate that if our organization's risk tolerance policies allow for it. So we're becoming more efficient at each stage of this SDLC or this pipeline as each type of testing technology builds upon the other. We really didn't discuss this today, but we could run a lightweight dynamic analysis solution to help support security in production environments. That's almost like a production extension of the value that we get from IAST. It's almost more bordering on that black box automated pen testing. But remember that we benefit from doing all this atop that unified scalable as a service platform noted in the blue there. And lastly, then in green toward the bottom of your screen, and denoted, well, rather, I guess, denoted by the red lines going toward issue tracking, all of these tests should deliver very clear and prioritized actionable risk intelligence and remediation guidance into our issue management workflows so that developers and anyone else that is required to do so can take action. We can increase the efficacy of all of this with two different types of developer security training. We're going to focus on enabling our developers to be more risk aware and more security capable at the start so that we can prevent the introduction of risks. And then we're going to provide them training and information that's relevant to the risks that we actually do detect so that we can accelerate remediation, which is basically reducing the duration of our risk exposure and increase the return on investment for our DevSecOps program. I guess lastly, we can pare this down even further, at least for today's conversation, to sort of reach a minimum viable requirement for what I consider to be an integrated DevSecOps solution, at least from Synopsys here. That's going to be with at the developer desktop with CodeSite, with the scalable hosted Polaris AST platform, with pre-production runtime testing with Seeker, and all that really engaging risk-relevant security training for developers, facilitated by our partnership with Secure Code Warrior. So I know we've covered quite a bit of material today. And I thank you for your attention. And I encourage you to take that 5-step process and collaborate with your colleagues on other teams across security, DevOps, development, get them involved, determine how they each define success, and where we can hook AppSec and security controls into the process and pipelines that already exist. So with that, I'll happily take any questions that have come through.
All right, Stephen. So we have received a lot of questions. So thank you to everyone in our audience for sending those in. Now, we won't have time to handle all of them. So any questions we don't get to, we'll be sure to forward along to the folks at Synopsys. So our first question, I'll pop it up on the screen. But we are habitual in developing apps first and then working on security and policy. How is policy centricity helping security risk and capability? Does it change the development first habit?
Yeah, that's a really interesting question. So remember that we're talking about trying to support developer first security. And so again, how do we enable developers to write more secure code? Again, part of that's going to be from just making them more security conscious and more security capable, because a lot of these issues, they enter into the code base either because of a developer might lack the capability to write more secure code, or maybe they're just unaware that what they're writing might be insecure, or they're using open source or something like that, and they're just unaware that there's a vulnerability present. Policies then come in where we say, well, how do we eliminate the subjectivity of what security is? And so that, because we don't want developers to get distracted by seeing these full lists of issues, when we just know that security teams the policy might write out half of them or a quarter of them. We don't want to waste more time fixing issues that don't matter. So it kind of depends on the implementation and integration of your security tools. If those policies that you define align to your risk tolerance, risk severity, OWASP top 10 violation, regulatory compliance, things like that. If your policies reflect those, we need to make sure that it's integrated into the developer workflows so that they then align to our standardized approach or standardized assessment of risk. So it kind of depends on the tools you're implementing, but ultimately the policies need to be conscious and facilitate the developer's workflows so that the two work in unison. Kind of a complicated answer.
Well, it was a big question, and we were following up with another. How does automation streamline security processes and enhance collaboration between development and security teams?
Yeah. So the easiest way I would say is closing and abbreviating those feedback loops. So eliminating kind of that one directional prescription of fixes or alerting of security issues from security testing that might happen later on down the line. Automating those tests, and more importantly, automating that feedback into those issue management systems. That's where we're closing that loop with development teams and between development and security teams. And so if that can happen automatically so that the security teams don't need to keep tapping developers on the shoulder saying there's a new issue, if we can automate the detection, align that to the policies we just discussed, and then make sure that feeds back into our workflows, now the security team can rest assured that developers are being alerted to prioritized issues that security really cares about without having that unnecessary intermediary step of actually manually alerting from the security team to developers.
All right, thank you for that. It looks like we have time for one final question, and it's coming from Paul. What kind of training would most benefit developers looking to utilize AppSec automation, and what kind of culture should be fostered?
Yeah, I really like this question. So I don't want to denigrate security training at all, right? Or in aggregate. Security training in whatever your role or your capacity is probably beneficial for the organization and for you as a professional. Developers, I think largely, secure developers, I had another data point that I didn't reference in this presentation, but increasingly managers are seeking to hire developers with formalized security training. And often that does not come from, at least historically, has not come from coding boot camps or universities. And whatever security training they may get, wherever they receive it, is not often aligned to the needs of the business. And so the benefit with security training, as we discussed today, we can align the more modular training to the risks that we detect, so that we're not overwhelming developers with unnecessary training, and we're providing training that is aligned to our business needs and the risks that actually exist within the code and within the projects. So things that help them, training that aligns to the languages, the frameworks, the technologies that they're using, I would prioritize those, align it to the risks that we detect, facilitated through that integration. And then honestly, helping developers be more valuable as professionals, because ultimately we are all working professionals. And so developers have a more vested interest in supporting security when that helps them in their careers and in the projects that they create.
All right, Stephen, thank you so much for addressing those questions with such depth. There were many questions we don't have time to get to today. So like I said, we will forward those along. But I do want to thank everyone for all of your input and feedback, your chats and your questions today. It really is what makes our webinars invaluable. Stephen, thank you so much for joining us today on Techstrong Learning. It has been such a pleasure.
Thank you.
So before I officially release our audience, stick around for just a moment longer. Couple of final notes. We have recorded our session today and we will be emailing it to you here shortly. You can also find it living on the DevOps website. Just visit devops.com/webinars. I will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you for your chats and your questions. Now there is a link in the chat to our survey if you wouldn't mind filling that out for us. It's also found in the handout section. I'd like to thank Synopsys for sponsoring our program today, and to everyone here in attendance, thank you so much for being here. We appreciate your time, and we do really hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Stephen.